Good afternoon, everyone. Welcome to today's webinar, our first of many to come. My name is Mike, and I'm the Technical Support and Automation Specialist here at Cadexair. I've been part of this team for nearly 2 years, and I'll be your moderator for today's session. It is my pleasure to present you, who will be doing the presentation today, our Chief Executive Officer, Francis Brassard. On behalf of the entire Cadexair team, I'd like to thank you all for joining us today. We're very excited to have participants tuning in from coast to coast Canada, and we appreciate you taking the time out of your busy schedule to be with us today. Today's session will focus on the implementation of the new NFPA 96 standard and the key regulations that are important to remember. Firstly, we'll review the significant modification of these regulations, how they impact the transition period leading up to October 17, 2026, and the implication for your projects related to the ventilation control and fire protection for commercial cooking operations. Please feel free to submit your questions in the chat box at any time during the presentation. And to use these features, please note for mobile devices, it is important for you to download the Zoom application rather than the browser version. Questions directly related to the topic being discussed will be addressed during the session, while the others will be answered at the end during the Q&A. For our viewers in the province of Quebec, this webinar is recognized as a valid training for both the Régie du bâtiment du Québec and l'Ordre des ingénieurs du Québec. So to officially open today's session, it's my pleasure to pass it on to Francis Brassard, who will share some opening remarks and set the stage for today's discussion. Francis, the floor is yours.
Thank you, Mike. So thank you everybody to be there. So I will just start by quickly introduce myself. So my name is Francis Brassard. I'm a chemical engineer from the Polytechnique of Montreal. I've been, I will say, working all my professional life in kitchen exhaust hood systems. So I have more than 18 years of experience in kitchen exhaust hood system design. And I'm the full control owner of Cadexair since 2017. So today we will explain about NFPA 96, the new change, and some recap about the most question I receive about NFPA 96. So everybody, I think they like to do it right. So we will try to explain a few points and give you some tips on how to do correctly a kitchen exhaust hood, the design of a kitchen exhaust hood system. So first thing first, we're here to talk a little bit about the code. I know sometimes it's a little bit a pain, but we need to understand how the code is going on. Because when you talk about NFPA 96, NFPA 96 is an American publication. So why this document have force of law in Canada? So we need to understand why. So technically, the first thing that will happen, it's every 5 years or so, the Canada will create a national building code and will be submitted to every province. But the important point to understand is all the construction or provincial jurisdiction. So each province need to accept the code. So some of them can accept it exactly as is, or other will do comments about it. So the provincial always have authority over the building code. After that, also you have all the municipality that can add up different stuff and be more restrictive than what happened on the provincial government. So right now, if we are having a project, we're in a transition period, so you have the choice to be as per National Building Code 2015 or 2020. So I will say mainly all across Canada, the new building code have been submitted by the province around March and May, as per your local province, and you have an 18-month transition period to explain, to choose which one you will use, because if you are doing already a project, just you want to not have a new set of rules to do it. Also, the objective of 2020 National Building Code is to have more harmonized around the province and Canada. So for the example, in Quebec, instead of publishing a full code, they just put out a booklet with all the difference you have between Quebec, Quebec code and national code, and other provinces are doing that. And just a quick reminder, municipal law need also to can also be implied in the kitchen exhaust hood design and be more restrictive than what could happen on the provincial part. So if we are looking at the NBC, the National Building Code of Canada, and in fact, mainly all provinces use this structure. So if you go to the article 1.3.1.2 in the new code, the 2020, you will say this is NFPA 96/2021 that will be applied. So later on, we will tell you what have been changed between the 2014 and the 2021. The article after that, 6.3.1.6, is the one that mainly called the NFPA 96. Everything have been put in I will say a little bit less word to be a little bit more compact for the PowerPoint. But in fact, as soon as you have commercial cooking equipment, you need to be complied with NFPA 96. And after that, they put some more information about if you use residential cooking appliance outdoor or residential outside of residential scope of work. If there's the probability to have more smoke and grease than the of a normal household, you will need to comply with NFPA 96. There are also another qualification. If you have like establishment assembly, treatment, or detention occupancy that could have more grease, they will also have a requirement for fire protection system and NFPA 96 and everything. And in fact, this for the article 83.3.1.2.2, we had like some senior home where they have maybe a residential appliance that could be used by multiple person, but each one have their room, so some of them need to add NFPA 96 exhaust system, others not. And at the end of the day, it's the municipal fire marshal that take this decision. And I will say the municipal fire marshal is mainly the person that you need to contact if you have any question about if you need or not to have commercial cooking appliance.
So following what you just said, to my understanding, Francis, is that the legal code is applied by the municipality or the province rather than the national code. Is that right?
Exactly. So at the end of the day, it will be the municipal that will, with the fire marshal, that are the foot on the ground that will check your system, ask question, and even submit permit to open the place. And I will say it will mainly the provincial building code that will be applied for the local regulation, but always check municipal code too. After that, now we have checked our project, and we have determined, okay, we need to comply with NFPA 96. So just to double check, when you look in NFPA 96, what also they are thinking about the using of residential equipment or thing like that. So technically, this standard the NFPA 96 shall apply to residential cooking equipment used for commercial cooking operations. So as soon you have commercial cooking operation as per NFPA 96, you should have a full commercial kitchen exhaust hood system. And that's a good example. If you have a restaurant and you put 4 electric range side by residential electric range, you will need to comply with NFPA 96. The article 1.1.4 is very important. It's when the standard will not apply as per NFPA 96. First, you need to only have residential equipment to be used. Second, you need to have the right extinguisher, portable extinguisher around the system. So if you have residential hood with everything, you still need to have an ABC kitchen extinguisher. And normally when we are in commercial cooking exhaust system, we will use what we call a type K extinguisher. It's a specific extinguisher that built for grease fire, but this extinguisher will conduct electricity, and that's why when you got a fire commercial exhaust hood system, we need to shut down the appliance to reduce the risk of electrocution if somebody use a portable extinguisher in fire. Also, the facility is not an assembly occupancy. Okay, we will come back later because it's really important about the assembly occupancy. And the authority having jurisdiction need to approve the installation. And like I already said a few times, it will be mainly the local fire marshal that will can tell you, no, you still need to comply with NFPA 96. Yes, Mike.
Sorry, Francis. We just got our first question from one of our participants. He wants to know, is a hood mandatory in a child care center or not?
Yeah, I will say this is not an easy question or yes or no. Now the childcare are still bigger and bigger and often have commercial cooking equipment, so they will need to have to comply with NFPA 96. After that, when you got residential equipment, normally they will produce more grease than what happened with a normal family, because often you have 50, 60 kids there. So I will say normally they will use it. But I will say, if you want to doubt, always double check with the fire marshal, and sometime a daycare center or business. So also sometime the insurance company could request to have commercial cooking hood system. So it's not a yes or no. Always to double check with the insurance company and also the local fire marshal about that. So when we're talking about just to return back to the presentation, so the facility is not an assembly occupancy. So technically, when you look at that, as soon as you have more than 50% that for gathering, deliberation, worship, entertainment, eating, drinking, amusement, awaiting transportation, or similar use. So if you're an assembly occupancy, as soon as more than 50%, you will still need to comply with NFPA 96. And if you need to, if people waiting in the bus near a residential electric stove, you will need to comply with NFPA 96. So that's a big limit. And often if you go in a really small city, they don't have really a lot of municipal law, and they will just say comply with NFPA 96. So if the certificate of occupancy is over 50%, I think you should put NFPA 96 hood. And after that, the scope of work of NFPA 96 is very simple. It's to vent cooking equipment that will produce grease laden, and to put everything as per code. In fuel line, as soon as you have to comply with NFPA 96, you have what we call a Type 1 hood or certified hood with filter in it, a sage gauge welding ductwork, and after that an exhaust fan, a full fire protection system for the ductwork, the hood, the fan, and for the hood and the equipment, not the fan, and often a makeup air as soon as you're starting to have a bit of a big system. Often also we will ask, and people are in the business, we also talk about a Type 2 hood. So what is a Type 2 hood? It's a hood for heat and steam. So how do we know if an equipment is for heat and steam or cooking or grease producing equipment? If you are like me and read the NFPA 96 with so much passion and you say, what can I read after that? You still can read the ASHRAE 154. So this is, I will say, also almost a better version than the NFPA 96. I think it's more easy to read and more straight to the point. But there's really interesting table inside of that. So I don't know if you see it correctly, but this is one of the tables that show all the equipment as per ASHRAE 154 that is for Type 2 kitchen exhaust hood. So rice cooker, steamer, kettle. I got one that I find funny in this. It's I don't know if we will see it correctly here. Oven, convection, off-size, electric and gas, non-protein cooking. I really like this because when we see non-protein cooking, it's always about to trust the customer. Like when I started in the business, I'm making a really small senior home with a six burner gas stove. That's it, that's all. And they have not a lot of space to pass the ductwork, need to put fire master or fire wrap around the ductwork, and don't have enough space between the stud and in the ceiling, not the stud, but between the structure. So they asked me, oh, they only were doing soup, so we can lower the CFM. So no problem, lower the CFM to 500 CFM instead of probably something around 800, 900. So we do the system. I personally did the startup at the time and went back, and after maybe a month after the startup, I received a call, it doesn't work, you smoke everywhere. So, oh, okay. So I went back on site, go back, check the fans, rotation, if all the rotation sense is okay, if there's no access door open in the ductwork, find anything, everything looks fine to me. So I'm going to speak with the chef. So what had happened? Yesterday night, we cook up 60 pork chop and there's smoke everywhere. So first thing I learned, you never trust your customer because you never know what he will do in the past. So when you have things like that, I will probably put a type 1 hood because I will never say that they will not do any protein cooking. So, and also I talk about ASHRAE, and maybe some people doesn't know what is ASHRAE. ASHRAE, it's a multiple standard that are produced by engineers in different field of activity. And ASHRAE 154 doesn't have any force of law anywhere, but I will say normally if you go somewhere and say I go as per ASHRAE, it's a really strong code, and they have people with a lot of knowledge doing that kind of stuff. So just to come back to the Type 2 hood, so a Type 2 hood is for vapor and everything, and there's something in the ASHRAE 154, they will say that if your kitchen equipment will have more than 5 milligrams of grease per cubic meter at a 500 CFM airflow, you will need to have a Type 1 hood. If you're under, you can use a Type 2 hood. And I will say, what is this? What is 5 milligrams? What it looks like, I don't know. I have zero idea about it. But something is sure, I make just a small verification. What is 5 milligrams of water? Is 0.0005 milliliter inside of 1 cubic meter at 500 CFM. So I will still with that. I cannot tell you what is listed equipment or not. But now there's test standard. It's a UL 197 listing with the EPA to test that will prove that the equipment will have a lower emission than the requirement for a Type 2 hood. So now there's a lot of equipment that have this kind of test. And if you look in the spec sheet, it will be on the top page because they pay a lot of the money to be there. And give you an example, I will say a lot of Canadians are on the road, so Tim Hortons is coast to coast, so everybody can have like a fried potato or thing like that from Tim Hortons, and they don't have any commercial cooking hood. It's because they use a listed cooking equipment with a catalytic converter, so they're listed to have less than 5 milligrams of grease per cubic meter at 500 CFM, so they can use normal kitchen exhaust hood, Type 2 kitchen exhaust hood system.
I'll have to cut you off again. We have two interesting questions from the Q&A from our participant related to this. So the first one, Francis, is if I only have one closed oven, am I required to have a fire protection system?
For a closed oven, as soon as you are Type 2 hood, you will no fire protection system is required. So if you go in the list and you say, okay, I have non-protein cooking, you will require to have no fire protection system. But if you have like a combi oven, a full convection oven, or a half convection oven with protein cooking, you will need a Type 1 hood, and every Type 1 hood needs to have a fire protection to protect at least behind the filter of the hood and also the ductwork. So if you have a closed oven, you will not have direct nozzle to the equipment, but you will be able to have nozzle everywhere else to protect behind the hood filter and also the ductwork.
Perfect, thank you. The second one is a little tricky question. Do I need a commercial hood for a panini press?
For a panini press, that's a good one. I will say, I will refer to the ASHRAE 154. They are listed as an equipment that not require a hood at all. So I'm almost sure there is no also a gas panini press. I don't think this is existing. So I will say normally you will be able to do it. But at the end, if you have a really weird application and there's a lot of grease and you are over the standard of 5 milligrams of cube of air, that could be required, but I will say 95% of the time this will be, and more than that, 99% of the time.
It would have to be a big panini.
yeah, exactly. After that, okay, so there's also some new rules about the energy efficiency code in the Canadian building. I will say this a little bit more difficult when you do this across Canada because, in fact, as per the airflow generated by the kitchen exhaust hood, as soon as you get more airflow than 3,000, 4,000, and 5,000 CFM, and I will explain why there's multiple value, you will need to have a demand control system. They also have two other requirements. If you have 50% of more of the exhaust need to still be exhausted by the hood when the hood is off or things like that. So they will use transfer air. You will not be required to have what we call a demand control system or to have energy efficiency system. So the purpose of that, or an example of that, we have done in hospital in the past, and because they have a lot of a surgical room, so they bring a lot of air to put it in positive pressure to be sure that all the contaminant will not enter the room when people have operation. So in that case, if you have a lot of fresh air that you need to put out of the building, and it's more than 50% of the hood, don't have to put a demand control system. The second point, if you need to have 75%, and that's I will say the most one used in the business. So when you're over your trigger of CFM, you need to have at least 75% of the airflow connected to a smart hood system, and which make it possible to lower the airflow at least 50% in the minimum flow. So in a few words, if you have at least if you are over the standard, you need to be able to modulate your airflow down to 50%. And just to double check and be sure, there's some makeup air unit that are not able to have modulation under 50% of the minimum airflow. The kitchen exhaust fan is not a big problem for them because they can lower a lot more than the makeup air, and mainly why the makeup air have difficulty to go down. It's because you have a lot of, for the heating, so you have gas burner or electric cord that you need to have a minimum speed to make it work correctly. So, but the exhaust fan, the only requirement normally is to be able to comply with an NFPA 96 that require 500 feet per minute inside of the ductwork. So that's why often this is used. The other possibility is to have thermal heat recovery on the kitchen exhaust hood system. I will not say I know every system in the world, but there's not a lot of heat exchanger. And normally to use an heat exchanger in a system, you need to do heavy filtration. I will not say, so to buy a filtration, to put a cord to save for demand control system, that's too much expensive. And also you need to change the filter, that will bring more cost. So at the end of the day, if you want to do heat recovery, you need to have a pollution control unit. If you're stuck with a pollution control unit, you can put a recovery energy coil, but I will not say put a energy coil to be able to save some money about it. So now I will try to explain you what is the difference. Yes, Mike?
I have another question that just popped up from another mic, so we'll introduce it right now. Would the manufacturer have data on the percentage of grease produced by their equipment?
I don't think so. Or there's some tests when they are doing the test, and we're just going back to the PA 202 about the 5 milligram of cubic meter. Yes, they will do tests, and if you go really deep down in the test, you can know what they were cooking. But at the end of the day, if you have like a closed oven and you put steak or really greasy stuff in it, you will maybe outside of the scope of work of what they are tested. So sometimes you need to double check and be realistic. So if they made a test with broccoli to pass the test, and after that you use it with, I don't know, a lot of greasy stuff, it's not always...
So it's more relevant to not the equipment, but what is being cooked with the equipment.
Yes, but you need to, when they list the equipment, you will have to pass the test, and some of them we have seen they use chicken breast, or often it's, I will say, a burger patty they will use in the test. But I never made a test about this kind of equipment, but it's always as per the type of, they will tell you what type of food. So normally, and also if you buy an oven that's doing something, you will use it in the purpose. But we often, in many years, sometimes people use equipment not the way they have been designed. We have already seen somebody doing cooking beef in the kettle. So I don't know, it will be good at the end of the day, but you're supposed to use the right type of equipment. So it's always, if the people use it correctly, it should be correct. If they're not using as per what all the equipment have been created, that could be sometimes a little bit more fun.
Perfect, thank you.
Okay, so just to continue, so we're talking about why it's 3,000, 4,500 CFM to require a demand control system on kitchen exhaust hood. In fact, it's come from this beautiful table, and how to explain it, it's not that simple. So they split the Canada in multiple zones, okay? And they use it with what they call degrees day, and in fact, it's the difference of temperature between normal temperature and outdoor temperature. So if you are in zone 4, you have 3,000 degree, and it's degree per day, so it's every day you have a total of 3,000 degree difference with normal temperature. And if you go in zone 8, it's 7,000. So more on the right of the table, I will say more your climate is difficult. And you've got the value of the National Building Code in liter per second. So I will say on the far left, it's 5,000. And after that, it's 180, it's 4,000 CFM, 3,000. And in fact, there exists a map that are on the in the building energy building code that will show you different stratification of. I have some difficulty here. You have different stratification. So 7, 6,000, 5,000, 4,000 is representing the degree days. So if we are going back to the table, you can see you have like, I will say zone 5, 3,000 to 399. So if we are going, if we're going back here, so we will be somewhere 3,000 and 4,000. So all the zone right here over Victoria will be that zone. So you have a split up for everywhere around Canada, and surprise, surprise, more you are in the north, higher is the value of the degrees day linked to the lower CFM to have demand control. And I will suggest you to always double check with your provincial code, because we double check, and I will say yes, we're better for all the rules in Quebec. So if we look at Quebec, we have multiple layer of, because more you go north, and even Quebec and Montreal not in the same zone. But if you look at the provincial building code, they will just tell you that it's 5,000 CFM everywhere in Quebec. So even if they put that in the building code, sometime you need to double check with the provincial. But to keep in mind that if you have over, I will say 4,000 or 5,000 CFM, in Halifax it's 4,000 CFM, or Nova Scotia, 4,000 CFM in New Brunswick. So always double check what is the requirement in your area. Now we'll start about the reminder of the NFPA 96. So the purpose of this, it's yes, the building code 2020 just come in. 2015 has come a little bit later, because I don't know if you remember something called COVID. So it was like 2 years later than normally. So the change was not that far. And I think that's a good way to go what kind of news or a change there were in the code. So the first one, they added now you need to interlock the kitchen equipment with the exhaust. So technically, as soon you start cooking, you need to exhaust turn on. So I will say there's multiple means of activation. So we can use like a temperature probe with a dry contact, like a high limit switch on the top of the hood. As soon we call it the detect because it's our demand control system. Normally, demand control system have temperature probe, so they can start the system also with a set point. We can use a current sensing ring on the cooking appliance. Or we can also interlock the cooking appliance, so you need to start the ventilation to give power to the cooking appliance, or also the gas. I will say we also in many years we had also a lot of these demand. It was not as per code, but they don't want to start something before the others. So, and we really think the temperature sensor is the best way to do it, because it's one size fit all. Okay, because as soon as you've got gas equipment, and I don't know if you already have worked in a kitchen, just to light a pilot light is a pain. It's really painful. So if you have a shutdown, if you shut down your cooking equipment every night, you need to restart the pilot every day. And I will say it could take like half an hour on a big job. Also, they have a lot of cooking or a lot of fire protection system that will work with a mechanical gas valve. So you will not be allowed to shut down the valve if it's a mechanical valve, because the valve will only shut down if the fire protection system is triggered. Also now, I'm not a specialist in all cooking appliances, but now if you look at combi oven, you have screen big like an iPad, so people will have to do some configuration, thing like that, program the equipment. So if every time you shut it down and open up, it can become difficult for them. Yes, Mike?
I have a question from another participant. Is makeup air required for all commercial kitchen ventilation system?
That's a good question. In fact, they will not say that a makeup air is required. As in the code, and I don't know the exact value, but somewhere I think in chapter 8, it's called air movement, they will say that you have a maximum differential of pressure that you can have inside of a restaurant. And there's a specific value, I don't remember it on the top of my head. But if you go, probably everybody has went to a restaurant, tried to open the front door, and it's really difficult to open. That's a case where there is no makeup air, or the makeup air is not running. But I will say I make job, and we have like a really compact system called a CRS36. It's 600 CFM. Normally, we always double check with the engineer what will be the source of fresh air for this system. So sometimes they can steal it from somewhere else in the building, because 600 CFM is not that much, or it's a small electrical residential cooktop. So in that case, yes, you can go without, or if you have enough air come from another system. But I will say mainly as soon as you go over 1,000 CFM, majority of the time you will need to add makeup air to the system.
So easiest way to gauge is if the door opens or not.
I will say if the door doesn't open a little bit too late, you need to see that before. It's sometimes the makeup air have failure. I will say makeup air is a really, with all the heating and often it's direct gas fire makeup air, so it's like a burner that's throwing everything inside. So you have all the combustion gas going inside. So they have some sensor in it that will check the quality of the air, and if the combustion is not good enough, you bring too much gas inside, or I don't know, the burning is not good enough, or the machine will just stop. So that could also be a reason why you have difficulty to open the door on a restaurant.
And just to get back to what we were discussing on the presentation, in summary, is that all systems that don't have interlocking are not compliant to the code. Is that correct?
Oh yeah, and it's not in the transition. So since the code 2015 will be have been enforced, and then it's probably sometime around 2022. You should have a way to interlock to be as per code.
So it's not part of the new regulation. It's already been implemented.
They should have. Yeah, everybody should do that since the last 3 years if you want to do it correctly.
Okay, thank you.
Yeah, this one is the favorite from all the mechanical engineer and contractor, and it's still something not new, but from the 2015 version. Now the slope in the ductwork are now there's asked for a slope. So technically, all the ductwork, horizontal ductwork less than 75 foot need to have a 2% slope. And if it's more than 75 feet, they will ask for 8%. So just to bring that in the head of everybody, so we will jump directly to 100 feet of ductwork. You will lose 8 feet in the ceiling, and so it's almost like a residential story full. 8 feet is what normal ceiling are in a house. So that's a lot. So what I've been seeing on the market, and I will say it's always the authority having jurisdiction, and not a lot of them just will tell you what to do. But technically, we use 2% ductwork and do zigzag like this. So what happened? You will create low point. But the beauty when they put back this, they put in this new regulation. Now you can put a drain inside of the ductwork. So where you have two slopes going together, you will put a welded drain and also an access door to be able to clean it. And you need to put a bowel valve to be able to drain it. And while you have an access door, it's sure it will clog one day. because you know when you clean duct, it's not pretty nice white water coming out. It's deep grease, and at the end, it will be stuck somewhere. And I will say Cadexair have a lot of experimentation in that scope of work because we have more than 10 team cleaning hood at night everywhere across Quebec. So we had a lot of experience inside of that. So, yes, Mike?
Yeah, sorry to cut you off, but I have a question from another participant really related to this topic. Is it mandatory to install a valve when we have a drain in a slope duct?
No, you can only put the cap, or it's not. It's just to be able to be drained. So, but I will say for a kitchen exhaust hood guy, you prefer to have a valve. It's easier to work with it, and after that, often the cap. It's not when you. It's when you just put it back. If you don't screw it correctly, and you will not put any Teflon or thing like that, so it can drip. So I think a valve will do a better job. But I will say cap will still be as per law, and also the duct, the drain need to be fully welded. Also, I think I got an animated discussion maybe 6 months ago about that part in the NFPA 96. It's called the horizontal duct. So they will say that all horizontal ducts shall be provided with access in accordance with 7.4.1. What does it mean? So technically, when you got a ductwork horizontal, you're supposed to have access door every 12 feet in every change of direction, okay? But there's a way it's written down that if you have a 20 by 20 access door, the guy can come inside of the ductwork and do his job, and only one at each extremity. In our specific case, it was like a 50-foot long ductwork with a curve in it, and it was a 24 by 24, and they put two 20 by 20 inch access door. So I will tell you something. It's sure I don't fit in that kind of hole, and I will never ask one of my employees to do something I'm not ready to do. So I said, we were on site, I said to the engineer, okay, you will go in and wrap it out from one point to the other point. So yes, it's in the code. Maybe if your ductwork it's like a 60 inch by 60 inch, that's not a problem. But as soon as 2020, I found it a lot difficult to do. And also if you do that, you have to work with, in consideration of confined space workplace. So they have a ton of security to add to that. So I will say it's not something we suggest, so we prefer to have access, a lot of regular access. And maybe one other point through that, it's if the access door it's not easily accessible from a 10-foot top step ladder, we're supposed to have a safe workplace to work. Because our guy go a lot of a difficult place, and I will say we have probably two guys that should work at Cirque du Soleil, how they can handle everything, but it's not the way we should work to work safely. So need to have a little bit of thought about the guy that will clean the ductwork. And if you think there's a magical robot that will go through the ductwork and put out the grease, no, you put degreaser, you scrape it, power wash it. I would say probably other area better than Quebec because they don't ask to test for leak tests on the ductwork. But something is sure, and it's easy to complain about the contractor, but when they have to weld in the ceiling and there are some junction that need to be welded directly on site, it's not always easy to do. So when the weld is leaking, I will tell you it's not beautiful water. Other quick point, it's about what I've been asked, I will say almost every week, how to exhaust on the wall as per NFPA 96. I will say first thing first, there's two considerations I will ask. When you want to do a kitchen wall exhaust, you need to have 10 feet of clearance of non-combustible material around the exhaust point. So this is often if you have like, I don't know, a wooden structure or or anything on the outdoor of the building, it's not a combustible structure. You're not allowed to exhaust through the wall. And after that, you need to be in 10 inch of the property line. I will say this one, it's not often in the big city, it's really difficult. So I will say it's not fully followed by everybody. The duct need to be in slope through the cooking exhaust hood, because at the end, when you will have your fan, if the grease will flow, it will flow on the wall, and also it's a louver, it will flow on the wall. So you want the grease that go back to the hood or to the fan or to another lower point or drain that has been installed inside of the ductwork. Also, when you work with a louver on a wall discharge, you need to have to exhaust parallel to the floor or upward. Often we see exhaust flow going downward, and understand it's about to the louver will not let the rain goes in, but you push all the fire, the smell, and I will say a bit of dirty air on the people down the street. So you're supposed to shoot upward. And I will say often when you have to exhaust on a wall, it could be a problem because you are in a high density area. So as soon as you shoot higher in the air, you have a better dispersion of the smell and everything. The second most important point, because that's the first thing I tell, it's because it's on the other slide. So first thing first, when you want to wall exhaust, non-combustible, 10 feet around. And the other one, you don't need to have any fresh air intake. So if we look at this figure, and we're really in the middle right here, this point, the exhaust point, it's like the fan blowing you in the face, and you see all the wall. Oh, I have difficulty with my clicker. So if you have 32.5 feet high, fresh air, no fresh air intake, so this is door, windows, or any fresh air intake of HVAC system, so you will not be able to have an exhaust outdoor. I will say there's a lot of pollution control unit that can help to reduce that, but the difficult part as per code, it's not written down in the code. If you have a pollution control unit, you will be okay for all the fresh air intake. After that, it's need to double check with authority having jurisdiction. So if we do a quick recap, 32.5 feet top, 10 feet left and right, 10 feet, like everything in the bottom of the exhaust point, it's 10 feet. And there's a formula with the angle, but that to give you a good idea. So as soon as you exhaust on the wall, I will say you need to have no door or operative windows almost on the wall you want to exhaust. The other thing that we talk a lot is the fire-rated mechanical shaft. In fact, how does it work? I think it's easier to go directly to the picture. The first thing we need to understand about NFPA 96, it's you're not allowed to put hood in two different fire zones. So what is a fire zone? So everything that has been split with a firewall. So I will say if you have a commercial strip with 3 or 4, I don't know, restaurant, they will have all their own fire zones. So you will not be able to plug them together. Also, another example, if you're doing a big hotel, and on a big hotel, you have multiple kitchen, you have a restaurant, you have mainly often a ballroom kitchen, a production kitchen. So you cannot plug 2 kitchen on the same ductwork if they are 2 different story. So you will need to have different duct going outdoor. So I will say the main idea during this, it's technically as soon as you go outside of a fire zone with almost any other thing, they will have like a mean to stop the fire. So if you have a normal HVAC ductwork, they will use a fire damper. But in NFPA 96, you're not allowed to use any fire damper. So if you, how can I exit my fire zone without creating more problems? So in fact, the mechanical shaft, and the purpose of that is to create another layer that we are saying right there, that is the shaft, that will go up to the outside. And technically, if you are between the shaft and the fire-rated assembly, but you're technically in the same fire zone as the hood. It's technically, because it's maybe not, but that's the way to understand it. It's an extension of the fire zone of the kitchen up to outdoor. So there's a thing here. Everywhere when we work with the NFPA 96, they will ask you to have, for the hood, the duct, the fan, they will ask you to have 0-inch clearance of non-combustible material. So a hood can be on steel, concrete, anything is non-combustible. 3-inch clearance of limitable combustible. The most common limited combustible in the world is the gyps. So you're not allowed to put a hood directly on the wall, so you need to put a 3-inch spacer in the back. So it's pretty easy and common in the industry. And after that, you need to have 8-inch clearance of combustible material for the hood. So if the hood on a wooden stud in the back, you have to put an 18-inch spacer, or I will say you need to put special insulation. A lot of manufacturers have listing to that, so they will put an insulation wool, and that will be good. But the only place it's different, it's inside the shaft. So if we're going really inside of the shaft, there's a note here that is an 18-inch of clearance of combustible, nothing new. But it's less than 6 inches to limited combustible or non-combustible. So they want 6 inches to everything in the ductwork. And the main reason why, it's when you're in your shaft. And sadly, you had a big fire, the duct will, I will say, a bit of grease, and it's hot, becoming red. So all the heat will dissipate inside the interstice between the ductwork and the fire enclosure. So what happens, it's normally the heat will go up and go up and go up. So where's the slab from the building? If it's really go on the ductwork and there is no clearance, all the heat will stuck there, and now it will be hotter and hotter, and it could break the firewall, melt the ductwork. So in fact, what happens is the heat will go up and go up and go up, and as soon as you got a mechanical shaft, you're supposed to have a vented roof curb. So technically, this vented roof curb will allow the excess of heat to going outside of the shaft. So that's why they ask you that. And there's a few things we saw in this picture. As soon as you get a blast fan like this, you're supposed to have hinges to be able to clean inside of the fan and also to clean the ductwork. And they will say the curb need to be 18-inch high, and the point of discharge of any fan need to be over 40-inch. But I will say it's all standard in the industries, but sometimes it's good to know. Now the new change. So this is the new stuff, and I will say this one, it's not really fun, but that's why the kitchen exhaust hood business is interesting. It's always moving and always have some challenges in it. So now a kitchen, in fact, if we go back in time and we want to list the fire protection system, you can knock at UL door and say, I want to list my fire protection system as per UL 300. You will have a bunch of tests to do. But when you do it, you have three choices. You can be listed for 10 feet, 25 feet of ductwork, 50 feet of ductwork, or 75 feet of ductwork. So I will say everybody that wants to list a fire protection system will go for 75 feet of ductwork. And they're doing the test, and they really have at UL facility a ductwork doing a big S on the side of the wall for over 75 feet. So when they put grease, they do fire and test. And if you comply to the test, UL say, congratulations, you passed the test. And UL was saying, if you complete 75 feet test, you have unlimited range for your fire protection system. Now the problem, it's if you go in NFPA 13, many years ago they said, okay, because the ductwork have not been tested after 75 feet, because the UL test stopped at 75 feet, we need to put water sprinkler. That could be a problem, or it's not easy to do. So now NFPA 96 in the 2017 version, because we stepped from the 2014 to the 2021 version, they still have a new one in between the 2017. So they ask that when you've got hood on the same exhaust fan and everything, you need to have a fire, you cannot cover more than 75 feet of ductwork, and you need to have a simultaneous operation system or independent fire protection system to cover the next 75 feet. So now we have three options. So the first one, you go as per NFPA 13, so you will put a sprinkler inside of the ductwork. And that could be some issue. If the duct is outside, you need to have a special sprinkler or thing like that. After that, if you have an independent mechanical detection system in the exhaust ductwork, so we can use the same one we use in the kitchen exhaust hood. So we put a visible link, fire protection system, and the nozzle, so it will shoot there as soon as the visible link will melt as per the temperature. And the other one, we can use what we call a simultaneous release system. So we can hook it to the mechanical way or electrical way with the kitchen, with the system in the kitchen, and also shoot at the same time as the one have been shoot at the same time as the one inside of the kitchen.
So according to you, Francis, with what you've just said, between these choices, which solution do you prefer or recommend, and why?
There's a lot of pro and cons in each of them. I will say my favorite is if they do everything with the water sprinkler, because we will not be involved anymore. But there's a big project in Quebec, and now they apply this. And what I've saw on our side, I will not say it's across Canada, not a lot of people know how to put fire sprinkler inside of the ductwork. They don't know which kind of seal you need to have a penetration, because you cannot just do a hole inside the kitchen exhaust ductwork and put a sprinkler. The other thing, because we're doing a lot of kitchen exhaust hood cleaning, and I will say I'm pretty sure that a lot of people will not double check or change the bulb there, just to see how many company doesn't clean the ductwork correctly in our area. I doubt that people will like to open access door and change the bulb full of grease, when normally I will say sprinkler are in better areas. I'm a bit afraid. And also the other thing, it's people doing hood cleaning with power washer and detergent and chemical. All these really said will evolve during the time. I'm not that sure. The other one I said is the cheaper, so the independent mechanical system. So we work a lot with the NSOL system or the SFA from Safety First. So we put the detection line, we put the system, everything will be there. I got an experience a few years ago that they have done that for any reason, but the system have been forgotten. So the system have been installed 10 years before. The company that installed the system was not the company doing the biannual maintenance of the fire protection system. So the system have just been forgotten at this area. So and the system need to be inspected. So I think the best in between, it's probably the simultaneous release, because if the guy who installed the system is not the guy doing inspection, but if is a little bit of knowledge, as soon as you see that kind of, I will say, mechanical release, what we call an RMR with the NSOL system, it's need to ring his bell and it will be in his face. But if the system is at something around 75 feet of the kitchen, maybe in a ceiling, it's not easy to see. But if they're seeing the electrical or mechanical release system, I think it's a good way to be sure it will be done. This one is a bit more for Quebec about the new change. I think it was approved all around Canada, but sometime in Quebec we're a bit strange. So now it's have been listed that inside of the NBC and even in the differential booklet, explanatory guide on the NBC from the Quebec, that now we'll be allowed to use the fire barrier, fire master, or any ceramic wool that have been listed with ULC S144 as an equivalent of a mechanical shaft or to exhaust from the fire zone. So instead to really have the wall, the space, the ductwork, you wrap it up and down and you should be good to go as soon as you work with NFPA 20, the National Code 2020 or NFPA 96 version 2020. So that's a good news for all the engineer doing job and everything. Maybe another point that has been requested, and that could be a little problem, because as soon as you got a fire, normally you shut down every fan that exists. But now in NFPA 96, they will ask you to start the fan as soon as the fire protection system is activated. From my point of view, the main reason is they will use the fan to drag up the fire extinguishing liquid from the NSOL system, SFA system, that will rise through the ductwork. So that's why they request that. But I will say, as per my experience, normally before Nicole, they would say the exhaust fan will stay at the same state they were when the fire protection system was triggered. But we got a lot of call about, no, the fan need to be shut, but now there's too cold. But now this is what will be in request. Something is sure, when you work with the Cadexair control panel, we can just go inside of the control panel through the touch screen and can put what they want locally. So when we're stuck at the last minute, it's really easy to fix, but it's something that you need to understand. That's now when you will buy a kitchen exhaust hood system, the system will start when the fan the fan will start when the fire protection system is triggered. So
perfect. We have a few minutes left. Before we move on to the Q&A section, I'd just like to mention that, like I said at the beginning, this is our first webinar of many to come. And for the next two ones that are coming, the first one would be on the exhaust solutions in urban zones and mixed-use buildings. And the other one would be on the ABC of designing commercial hoods and centralized system. Two that will be a bit more interesting than looking at regulations and codes, but definitely worth subscribing once you get the email. Not to move on, a little note before we go to the Q&A. For any engineers who currently have ongoing projects or upcoming projects and really want to do it right, make sure the regulations and laws are followed adequately, please feel free to contact us if you have any questions or want to obtain prices and quotes. The information is on the screen, as you can see right now, so don't be shy. It's our profession, and always a pleasure to talk to you. We will now move on to the Q&A period and answer any questions that you guys would have. So feel free to write them in the chat box, and we'll address them right now with a few minutes left over. Actually, I have one already. This is actually going quick. What is your opinion on usage of ventless hoods, Francis?
Ventless hood, yeah. That could be a good solution, but I will say in my experience, I remove more ventless hood than I sell ventless hood. And I will not say there are some good application. The only customer we have that really like the ventless hood is the Montreal Bell Center, because they don't care and they are happy because it smells fry everywhere and they try to sell fry. But normally when you operate that kind of kitchen with a ventless hood, you have no air supply or not a lot of exhaust. And often they will have requirement in the spec of work to have that amount of air change and everything. But what often happens, it will be hot in the kitchen. And because you also always recirculate it, and the smell stay there, because you don't exhaust a lot, so it smells, and as soon as you got any problem left or right, the smell can move in the building and you will have complaint, and also it's expensive to maintain. But in some case, if you are like in patrimonial building that you're not able to run ductwork, you cannot do a hole on the wall to pull out the ductwork or louver, that could be, I will say, it's not even a plan B. I think it's a good plan C or D in kitchen exhaust hood. But you do this when you're stuck, and also it's expensive to maintain because there are a lot of filters that you need to change. But it still could be a solution for a lot of persons.
I had another question asking if the webinar would be available. Yes, everything is recorded, and we will publicize it on our YouTube channel in the following days. So just stay tuned for that, and yes, you will be able to review all the information Francis so carefully explained today. I think so far we don't have any more questions. So unless you guys have more to put in right now, we'll put an end to it. We're ending at 2 minutes, so I guess we're good on time.
I'm happy I'm on time. It's always more than what we require. I cut a lot of slides just to be sure to be there. So like I said, we speak with a lot of engineer, contractor, owner, and I will not say that kitchen exhaust hood is space rocket, okay? But it's a lot of small detail that you need to know. And because Cadexair, it's a company that will be 40 years old next year. It's been 20 years that, almost 18 years I'm doing kitchen exhaust hood system. So I will say we learn a lot from these. And if you want to do it right, and if you want to feel the experience, just give us a call and we will be able to solve your problem And also, we have a lot of new stuff that coming in the next webinar that we create for, I will say, mixed-use building, or if you need to exhaust in a strategic point with smoke and smell will be a problem. So this is what we will do in the next webinar.
I have another, maybe a last question, but we have 1 minute left. So what is the maximum size for wall fan that can be used?
Oh, that's a good question. Normally what happens with the wall fan, it's when you go bigger and bigger and bigger, the motor HP will go bigger and bigger. And the motor is really heavy. So the motor will be on the side and it will tend to bend the fan. So we work a lot with pen barry at Cadexair, and we cannot put over a 3 HP motor. So I will say, maybe other manufacturer can offer more CFM and more different stuff, but I will say over 4,000 or 5,000 CFM, that could be an issue. But in that case, if you want to exhaust through the wall and maybe you have 10,000 CFM and not 10,000 CFM, I'm not sure any manufacturer will supply. You can use an indoor fan, an inline fan inside of the building. The inline fans are more expensive and they're also noisy. But at the end, if you need to move 10,000 CFM, that could be good. But I will say, top of my head, 4,000 CFM, 5,000 CFM should be the maximum that we can go. But we need to double check a real selection. And also it's depend on the static pressure of the system. Higher is the static pressure, bigger will be the motor. So, but in that area, that should be good.
Perfect. Thank you very much for everyone for attending, and I hope to see you in the next webinar that we'll do in January if everything stays up to schedule. Thank you very much. Any last words from the President?
No, thank you for your time, and I hope you appreciate it. So, and we have more information and more solution directly. I know rules and regulations, it's not fun, but it's the base of everything. So thank you for your time, everybody.